Hi everyone. So today we're going to start talking about your Earth Science reference tables, page 8 and 9. So make sure you have that ready. So with Earth Science reference table, page 8 and 9, this chart is showing the geologic history of the Earth and more specifically New York State. So it's showing the history that we found throughout the world, and it's more focused on New York State as well. The history of the rock record, all the fossils that we found within New York State and throughout the world. So we're going to start with reference table page 8 and move on to page 9, and you'll notice that the top row shows eons, eras, periods, epochs. What are those? So, eons, eras, periods, and epochs are divisions of geological time. Just like hours are divided into minutes, and minutes are divided into seconds, and seconds are divided into milliseconds, eons are larger units of time, kind of like hours, which are divided into eras, smaller units of time, like minutes. Eras are divided into periods, even smaller units of time, like seconds, and periods are divided into epochs, which are even smaller units of time, like milliseconds. And these are units that we use to measure our geologic history, which is a very long history since the beginning of the universe and the beginning of the solar system. So, eons are an indefinitely long period of time. This is the longest unit that we use for the longest period of time that we can measure. So, in this chart, you can find the eon column all the way towards the left, and you'll see that we have two types of eons: Precambrian eon and the Phanerozoic eon. And it also shows the dates of the different eons, when they started and when they ended. So the Precambrian eon are our oldest eon, and it started 4,600 million years ago, and it ended around 500 million years ago, or 570 million years ago. And the Phanerozoic eon started around 570 million years ago, and it's still going on till the present. And so the million years ago can also be asked in billions of years. So the regents may ask you the same time in billions of years. So 1 billion years is 1,000 million years, which means 4,600 million years in the bottom can also be called 4.6 billion years. So, the Precambrian eon is our oldest eon, and it can be further divided into smaller eons. So, the Precambrian eon is also divided into the Archean and Proterozoic eon. The Archean eon is divided into early, middle, and late Archean. The Proterozoic eon is divided into early, middle, and late Proterozoic. So, this helps us divide smaller units of time so we can keep track of the Earth's history. So, if we look at what's written on the sides next to the early Archean, it tells us significant events that have happened in that period of time. So, in our early Archean eon, first 4,600 million years ago, it was the estimated time of the origin of the Earth and the solar system. So, these are all the planets and the sun forming around 4,600 or a million years ago, or 4.6 billion years ago. And then around very close to 4,000, maybe 4,300 million years ago, we had our oldest known rocks. And we know how old they are based on elements such as uranium and lead in them. Then, in around 3,800 million years ago, we have evidence of biological carbon. So, carbon is a critical component of life, and all living organisms, plants, animals, and humans, have carbon or carbon containing molecules. So, to find carbon or biological carbon in our rocks showed us that there was some evidence of life around that time. So, around the early Archean era, there was no oxygen. There were just gases, such as carbon dioxide, nitrogen, hydrogen, and water. And these gases were coming out of volcanic eruptions. There were lots of volcanic eruptions happening. The earth was very hot at that time. It was just starting to form. And because of all the volcanoes were outgassing, which is the release of gases from volcanic eruptions, these gases, but no oxygen was coming out. So let's go over some vocabulary. Microfossils are tiny, fossilized remains of microscopic organisms such as bacteria. Cyanobacteria are bacteria capable of producing oxygen through photosynthesis. Stromatolites are one of the first cyanobacteria that existed. So around the the end of the early Archean, we had our earliest stromatolites and our oldest microfossils. So we have our oldest, tiniest fossilized remains, or we found these remains of the tiniest living microscopic organisms, and we also found stromatolites, which were our first cyanobacteria. And what happened is, this is an example of a stromatolite, meaning these are our rock layers, and in between the layers, you can find tiny ancient bacteria. And then in the middle and late Archean, we had oceanic oxygen produced by cyanobacteria combining with our iron, forming iron oxide layers on the ocean floor. So the cyanobacteria that was creating oxygen through photosynthesis started combining with iron and forming these layers on the ocean floor. And we call these layers stromatolites as well. And then in the early Proterozoic era, um, or eon, oceanic oxygen begins to enter the atmosphere. Since these cyanobacteria were creating lots of oxygen, these cyanobacteria were mostly found in the ocean, that oxygen started to begin to enter the atmosphere. So this is what cyanobacteria look like today. These bacteria create oxygen, but in ancient times, around the Archean eon, cyanobacteria looked like this. So, finally, in the middle Proterozoic eon, we had our first sexually reproducing organisms, and this is not well documented in our fossil record, so the precise identity of the first sexual reproducing organisms are still uncertain, but we do believe that they were simple celled, kind of like this, and they were capable of transferring DNA with one another. So go ahead and try questions 1 through 8 on your worksheet for ESRT page 8 and 9 practice on your own.